Hey everybody, and welcome to our next video in our second unit in food chemistry, which is going to be all about the different types of matter. So in this particular unit, we're going to start talking about chemicals in food and additives in food and preservatives and all of that. So this is a good place to kind of not only talk about those food related things, but to also bring this back to chemistry, because this is really what the course is about, and to talk about how do we categorize matter. So the question is chemistry and cooking really related? I hear a lot like, how are we going to talk about science and food? That doesn't make any sense. But if you remember everything we've been doing thus far, of course, chemistry and cooking are directly related to another. You have to manipulate different substances in your kitchen in order to make something new. There are chemical reactions that are occurring. And anything that we encounter in the kitchen is going to be made up of different chemicals. So I have all of these different images here that you would find in the kitchen. There's some pasta, there's garlic, basil, steak, even the pots and pans you're cooking with, chocolate chips. All of these have something in common. And what these all have in common, and really everything that we can think of, is that all of these different substances are what we call matter. And matter is literally anything that takes up space. So for us to call something matter, it has to take up space. And something that takes up space, guess what? Is like literally everything we can think of. Everything in the kitchen that you can touch is made up of matter. Even the air in between you and whatever you're cooking, that air is taking up space from here to here, right? That's space. That has a specific volume. So this air is also matter. So I always say literally 99% of the things we can think of is made up of matter. Everything takes up space. And I love this meme. I'm a big fan of Tim and Eric. So this is a little thing from Tim and Eric. I love this guy where he's like mind blown, right? Literally everything is matter. So what we can do is not everything is the same type of matter. So we could categorize matter in a couple of different ways. So matter can be categorized as one of two subcategories, and those subcategories would be pure substances, or we have mixtures. So matter is the big thing. Everything is made up of matter. Matter is either going to be a pure substance or it's going to be a mixture. Let's go ahead and differentiate those two first. So a pure substance would be something that's made up of only one type of particle, and that's it, one type of particle. I'm going to show you the more chemistry representations to get started, because I think it's easier to consider the chemistry representations and then take a look at the food examples. So here are some examples of pure substances. So if I take a look at this first container, so we'll call this container 1, we'll call this container 2, and we'll call this guy container 3. Container 1 has this particle right here. This is some type of particle. It has the same exact particle nearby, and it has the same exact particle nearby. All of these in this beaker are the same exact particle. Because they are the same, it is a pure substance. The same thing goes for beaker 2. This particular particle is exactly the same as this particle, which is exactly the same as this particle. Because every single particle is exactly the same, that again is a pure substance. If I look at this last one, so even though within these pure substances, so these particles are made up of different types of elements, which we're going to talk about in a little bit. But this right here is one type of particle, even though there are different circles that make up that particle. This particle is exactly the same as this particle over here, which is exactly the same as this particle that's up here. So because all of those particles are exactly the same, that is a pure substance. On the other hand, mixtures have more than one type of particle, and these particles are not chemically combined. So for example, here are two mixtures. So if I look here, this first beaker almost looks like a culmination of beakers 1 and 2 from the pure substance side over here. So if I consider the substances in this beaker, it looks like I have this type of particle, but then I have this type of particle. These particles are two different types of particles, and they are not bonded to one another. They simply just exist next to one another. That would be an example of a mixture. These two types of particles are mixed together. Here's another example. This is actually a culmination of all 3 beakers of the pure substances. So here I have one type of substance. Here's one type of particle, we'll say. Here's another type of particle. I have the red ones. But then I also have this type of particle. So there are 3 types of particles that are within this one container. And because they're not bonded to one another, they just exist next to one another. This is what we call a mixture. Bringing this back to the kitchen, let's talk about examples of pure substances in mixtures. Great example of a pure substance is sugar, actually. Sugar, which we've already talked about, has a fancy name, which is sucrose. So that's C-S-U-C-R-O-S-E, sucrose. And sucrose has a formula of C12H22O11. So its individual particles have that combination of elements that make them up. Every single particle is exactly the same. Another example of a pure substance would be a copper pot. The only thing is it has to be 100% copper. So in that particular pot, every atom is exactly the same. It's all made up of copper. That would be what we call a pure substance. Every particle is exactly the same. Mixtures. I love a good Italian wedding soup. I swear I make one of the best Italian wedding soups. But this is an example of a mixture. I think it's very obvious that we know this is a mixture. It's got a whole bunch of different things that comprise it. There's carrots, there's meatballs, there's pasta, there's broth, and we could see those different parts. Another example would be cake batter. So cake batter is made up of a lot of different things. If you've ever made a cake, which I'm sure you all have, you have to add one of 2 ways. If you do it from scratch, you would have flour, sugar, baking soda, baking powder, eggs, blah, 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 all of those things. And you mix them together and we get this batter. Or if you're making it from a box, you have the box mix, and then you have the oil and the eggs and whatever else you may have to add. That's also considered a mixture. It still has all of those things in it, but they're still chemically separated from one another. So we would consider that a mixture. However, we can also categorize each of those 2 categories into smaller subcategories. So everything is matter. Matter can be comprised into one of 2 categories, pure substances and mixtures. There are also 2 types of pure substances, and there are 2 types of mixtures. And we have elements and compounds, which are both types of pure substances. And we have homogeneous mixtures and heterogeneous mixtures. So let's go ahead and differentiate between those 2 different types. So pure substances could be one of 2 things. They're either elements or they could be compounds. An element is the smallest unit of matter, okay? And I can't break down atoms or elements any more than they already are. They're already broken down to their smallest amount. And we can tell all the elements just by looking at the periodic table, right? Everything on the periodic table is in its elemental form. So for example, if I am making some sort of a dish, and a lot of times if it's a really bougie place, they'll sprinkle like little 24-karat gold flakes on something. That gold is elemental gold. That gold is an element on the periodic table. It has a symbol of AU. So in that sample of gold flakes, that is a pure substance because everything in that jar is a gold atom. But gold is also an element. I can't break down gold any more than it already is. We also have compounds, which are basically combinations of elements that are bonded together. These are chemically combined to one another. So a good example of a compound, more than one type of element, would be baking soda. And this one is the trickiest for me to come up with examples for. And there's a giveaway for these. Like normally you'll know if something is a compound because I'm going to do something very specific. And what I'll do is I will actually give you the formula. So let me move my picture here so you could see, but there it is. So here I gave you the formula for this because otherwise you wouldn't really know what elements make up baking soda. But in a box of baking soda, we have sodium atoms, we have hydrogen atoms, carbon atoms, and 3 oxygen atoms. All of those elements are bonded together to make one more complex particle. And that complex particle we know as sodium bicarbonate. In the kitchen, we know that in its more basic term, which is baking soda. So every single white grain of dust in a box of baking soda is a sodium bicarbonate molecule, okay? So we can categorize them in one of 2 ways. Elements are just one element on the periodic table. Compounds are culminations of more than one type of element. And we can tell because I will always give you the formula for that. Mixtures, on the other hand, we can also categorize into 2 subcategories. There's homogeneous mixtures, and homogeneous mixtures it's a blend of more than one type of material, but you can't see the individual parts that make it up. So for example, wine is a homogeneous mixture. Wine is made up of a lot of different compounds. You have, first of all, water in there. You have ethanol, which is the alcohol part. You have different flavor compounds that lead to all of the different flavors of the wine. And sure, there's different sugars in there as well, depending on how sweet the wine is. However, if you look at a glass of wine, you can't see all of those different parts. It just looks like one liquid, right? One thing. It's uniform in composition. So as a result, we can categorize wine as a homogeneous mixture. It looks like one thing, but it's really made up of a lot of different things that are not chemically bonded to one another. Heterogeneous mixtures, I think, are the easiest to identify because these are mixtures that have different visible parts to them. So a great example is sushi. If I take a look at these sushi rolls, I could see the different parts to it. It looks like, in this case, maybe it's a piece of crab. I don't know what's in there. There's avocado, there's rice, there's the seaweed on the outside. This has different visible parts to it. So because I can physically see all of those different parts, we would consider that a heterogeneous mixture. So mixtures on their own are made up of multiple different substances. Homogeneous, though, looks like one thing, whereas heterogeneous does not look like one thing. We could see the different parts to it. So here's a different way that we can kind of categorize matter. Matter is everything. Everything you can think of as matter, with a few exceptions. Something that's not matter would be like electricity. Electricity does not take up space. You could also consider a dream is not matter. A dream also does not take up any space. Those are a couple examples that I can think of. I'm sure we can think of more, but mostly everything is matter. Everything in the kitchen is made up of matter. Except if you have an idea. An idea is not matter. Sorry, 99.99% of everything. A pure substance is just one type of thing, whereas a mixture is made up of many things, okay? So that everything is either one thing or it's many things. And then we can categorize those substances by looking at elements versus compounds. Elements we can determine by looking at a periodic table, and compounds are always a mixture of different elements. They're a combination. I don't want to say mixture. They're a combination of many elements on the periodic table. Homogeneous mixtures, we're going to say they are the same throughout, Whereas heterogeneous mixtures, these have different parts to them. So looking at this type of flow chart might help you to identify how would I categorize a certain type of matter in the kitchen. Let's go ahead and use this to do some examples together. So let's look at this jelly donut. What type of matter would this jelly donut be categorized as? A jelly donut would be a heterogeneous mixture. Why is that? I could see the different visible parts. I have the jelly as one part. I have the powdered sugar, and I have the actual donut part. So there's 3 visible parts to this that I could see. And next we have aluminum foil. What would we categorize aluminum foil as? What do you think is its type of matter? Aluminum foil would be a pure substance element. How do we know that this is a pure substance element? Hopefully, as we progress through this unit, you're going to start getting a little bit more familiar with the periodic table. So here's the periodic table, and anything that's on its own in a sample would be considered a pure substance element. And if I look, aluminum is located right here. So because aluminum is just one element on the periodic table, this would be considered a pure substance element. Anything that's on its own would be that. So before I said the copper pot, that a copper pot would be an example of a pure substance element, I know that because copper on the periodic table is located right here. So anything that's just one element would be considered a pure substance element. There's also not very many examples I can think of for these because how many elements really do we find in the kitchen? So you'll tend to see the same ones over and over again. How about the next one? This is cream of tartar. See if you can determine what type of substance this is. This might have been confusing, but we categorize this actually as a pure substance compound. So again, it's hard for you to tell what this is without me giving you the formula. So what I would do typically is I would tell you that cream of tartar is made or is potassium bitartrate. And potassium bitartrate has a formula of KC4H5O6. So there's 1 potassium, 4 carbons, 5 hydrogens, and 6 oxygens. They're all bonded to each other. That tells us, that gives it away that this must be a pure substance compound. Cream of tartar or potassium bitartrate is typically used to make meringues. It helps to stabilize a meringue so it makes it nice and tall. And we get potassium bitartrate, actually, it's a byproduct of winemaking. So wine has tartaric acid in it, and the conjugate base of tartaric acid is bitartrate, and we can make cream of tartar from that. So that's kind of interesting. It comes from wine, and we use that to help make meringues and stuff. Last example, I have Gouda cheese. What type of substance would this be categorized as? Hopefully you said for this is a homogeneous mixture. So cheese is not an element on the periodic table, believe it or not. Cheese is also not a compound. It's not just a couple of elements that are bonded. In order to make cheese, we need a couple of different things. We need milk to make cheese. We need salt to make cheese. We need some bacteria, and we need enzymes. So there's 4 different components for cheese that are necessary to make it. All of these don't react together to form something totally new. They just exist next to one another. So all 4 of these ingredients together make cheese, and because I can't see those different parts to the cheese, it would be considered a homogeneous mixture. And cheese making is a crazy chemistry experiment in itself because you can make any type of cheese from those 4 ingredients right there: milk, salt, bacteria, and enzymes. Depending on what bacteria or enzymes you use and how long it ages and the conditions that it's in, makes a variety of different cheeses, which is pretty cool. Anyway, if you have any questions on this, please let me know. But otherwise, this might be the only egg puzzle for this unit, which is exciting news for you. But otherwise, I will see you in the next video. Not sure what it is yet, but we'll see when we get there. Have a good day. Bye.